Bem-vindos ao nosso espaço, um mergulho profundo nos assuntos mais interessantes de esportes, ciências e temas gerais do momento. Aqui você vai encontrar conteúdo de qualidade, com análises empolgantes e descobertas fascinantes que vão expandir seus horizontes. Nossa missão é trazer informação relevante de forma dinâmica e descontraída. Queremos que você faça parte dessa jornada incrível de conhecimento e diversão. Se gostar do nosso conteúdo, não esqueça de deixar seu like e se inscrever no canal para não perder nenhuma novidade. Ative o sininho também. Aproveite!
If you love science, don't forget to like and subscribe. Imagine a world that has never seen the sun. A place miles beneath our feet where the pressure is immense, the heat is stifling, and the darkness is absolute. For decades, we believed this deep subsurface environment was a barren wasteland, a tomb of solid rock. But recent discoveries have revealed a sprawling, hidden kingdom, the deep biosphere. This subterranean world may contain up to 15% of all the Earth's biomass, consisting of microorganisms that live within the tiny pores and fractures of the crust. But here is the central mystery: what fuels them? While some rely on chemical energy from the Earth's internal heat or the radioactive decay of uranium, a fascinating and speculative new theory suggests another source of power: the Neutrino Garden. Neutrinos are often called ghost particles. They are nearly massless, carry no electric charge, and move at nearly the speed of light. Every second, trillions of them stream through your body without you ever feeling a thing. They are born in the nuclear furnace of the sun, in the heart of distant supernovae, and in the decay of elements. Because they interact so weakly with matter, most neutrinos pass right through the entire Earth as if it were a pane of glass. However, most is the operative word. In the vast, dense expanse of the Earth's crust, a tiny fraction of these ghost particles do collide with the nuclei of atoms. Scientists are now asking, could these rare collisions be enough to sustain life? This brings us to the concept of the Neutrino Garden. In the surface world, life is driven by photosynthesis, the process of turning sunlight into chemical energy. In the deep subsurface, life must find other ways. The traditional view is that life deep underground survives on hydrogen and oxygen produced by radiolysis, the process where radiation from rocks splits water molecules apart. But the neutrino theory takes this a step further. It suggests that the constant rain of solar and atmospheric neutrinos provides a subtle but consistent energy input that can trigger chemical reactions in the deep crust. When a high-energy neutrino strikes an atom in a water-filled rock crevice, it can kick off a cascade of subatomic events. This collision can displace electrons and create free radicals, which in turn react with the surrounding minerals and water to produce molecular hydrogen, the ultimate fuel for many deep-dwelling microbes. These organisms, known as lithotrophs, literally eat rocks by processing these chemical gradients. In this sense, the neutrinos act as an invisible sun, providing a faint, ghostly glow of energy that filters through the entire planet. If this neutrino garden hypothesis is correct, it would redefine our understanding of where life can exist. It would mean that the habitable zone of a planet isn't just a thin skin on its surface, but a voluminous three-dimensional space extending deep into its core. The implications for astrobiology are staggering. Consider frozen moons like Jupiter's Europa or Saturn's Enceladus. These worlds have thick icy shells that block out all traditional sunlight, making surface photosynthesis impossible. However, neutrinos can penetrate those ice shells with ease. If neutrinos can fuel chemical cycles in the rocky cores of these moons, they might support vast ecosystems in the dark, salty oceans hidden beneath the ice. We are currently in a golden age of neutrino detection. Massive experiments like Super Kamiokande in Japan and the IceCube Neutrino Observatory at the South Pole are teaching us how to catch these elusive particles. At the same time, deep drilling projects are pulling up samples from miles below the seafloor, finding life in places we once thought impossible. The Neutrino Garden represents a bridge between the smallest things we know, subatomic particles, and the largest systems of life on our planet. It suggests that even in the deepest, most isolated corners of the universe, nothing is ever truly alone or disconnected from the cosmic flow of energy. As we continue to probe the depths of our own planet, we may find that we are walking on top of a vibrant, hidden world. One that is quietly whispering to the stars through the medium of ghost particles. The next time you look at the ground beneath your feet, remember that it might not just be dirt and stone. It might be a thriving, invisible garden fueled by the most mysterious particles in physics. The search for life is no longer just about looking up at the sky. It's about looking deep into the silent, vibrating heart of the Earth. For more incredible facts like this, don't forget to subscribe and turn on notifications.